This is the screencast for example 2 of section 5.5. We are given some information of a non-right triangle, and we've got to find or solve the triangle, all angles and all sides. Specifically in this one, we are given side-side angle, which if you remember your geometry is telling you never say side-side angle. That is a bad triangle. In example 3, we will deal with why side-side angle is a bad triangle. It's not necessarily a bad triangle, but it can cause some complications. In example 2, though, however, we're not going to worry about those complications just yet. We're going to work on using the law of sines to solve them. So I'm given an angle of 26.3 degrees for angle A and side A. So I can set up my proportion just like example 1 and cross multiply. So 7 sine of B equals 6 times the sine of 26.3 degrees. Let's see, the sine of B then is going to be 6 times the sine of 26.3 degrees all over 7. I'm looking for angle B, so what I have to do is take the inverse sine of both sides. So now angle B is going to be whatever the inverse sine of 6 times the sine of 26.3 all over 7 is. And if you make sure you are in degree mode in your calculator, you get B is approximately equal to, we are going to have to round this, 22.32 degrees. Now I have to find, let's see, I know angle B is 22.32 degrees. I know side B. Now I need angle C and side C. So I'm going to take 180 degrees minus the 26.3 I was given for angle A minus the 22.32 I just found for angle B, and that leaves me with 131.38 degrees for angle C. So now I'm going to start out with the same proportion I started out with before, similar to example 1, just because I know that information. I know that 26.3 is an exact measurement of angle A, and 7 is the exact measurement for side A. Now I can say the sine of 131.38 degrees divided by C. Now in my calculator I have actually stored 131.38 and it's following decimal by taking 180 minus 26.3 minus the answer I got when calculating this. So I am using the exact value all the way along. Be careful so there's no rounding error. Now I can cross multiply again. And C is going to be 7 times the sine of 131.38, and lots of messy decimals after that, but I'm not writing them down, I'm just using them in my calculator. So I get that C is approximately 11.85. Just because this is getting a little bit messy, I'm going to put another triangle down here. I got that C is 131.38 degrees, so this will be my final triangle. Very easy to see. Very easy to tell that the biggest side is across from the biggest angle. And then I found that angle B was 22.32 degrees. Now, the now try problem, number 9, same exact setup. We're dealing with a triangle that has side-side angle. I'm telling you that there is only one possible triangle for this one. We're not going to worry about any complications just yet. I've already set up the sine of angle A divided by the length of the side of side A equals the sine of B divided by 11. So I can cross multiply 17 sine of B equals 11 sine of 32. So sine of B equals 11 sine 32 over 17. After taking the inverse sine of both sides, B is going to be the inverse sine of 11 times the sine of 32 divided by 17. And in my calculator, I get that B is about 20.05 degrees, but I have stored that as a letter. I've stored it as B because it just makes sense, so that I can reuse that value. Specifically, I need to reuse that value first off to find angle C. I know that angle B B is 20.05 approximately. So now angle C is going to be 180 minus the 32 degrees I was given for angle A minus the 20.05 I just found for angle B. And that means I get 127.95 degrees. So now I'm going to set up the initial proportion again because I know that angle A is exactly 32 degrees. I know that side A is exactly 17. And I'm going to set that equal to the sine of 127.95 degrees divided by side C. Again, I'll cross multiply to save us a little time. C equals 17 times the sine of 127.95 degrees divided by the sine of 32. So C is about 25.30 units. Now I want to put that on my final triangle. Let's see, I got that angle A is 32 degrees, and I know I put it in a different place up here, but it doesn't matter. Your triangle, as long as the 32 degree angle is opposite the 17 length side, then let's see, across from the 11 side is angle B, so that's 20.05 degrees. Then side C was 25.30 units, but angle C is 127.95 degrees.